This is for Year 12 Specialist. It comes out of Chapter 13, 13B number 13, and it's to do with the apparent weight in a lift. Okay, so we know that when we have a lift and we have an object, we're going to have mass times gravity, and this is going to be my apparent weight. So we know that when it is accelerating downwards at 1 meters per second squared, so downwards acceleration equals 1, we're told that the apparent weight is 2.5 kilogram weight. 2.5 kilogram weight equals 2.5 G newtons. So I know that the apparent weight is 2.5, so that's going to be 2.5 G. So now I'm going to write my resultant force to find out what M is. I don't know what the mass is, and I need the mass to find out what these two answers are. So the resultant force in the direction of motion will equal anything in the direction of motion, mg, minus anything in the opposite direction, 2.5 g, and that m times acceleration will equal mg minus 2.5 g. Therefore, m minus mg equals negative 2.5 g. So I'm going to swap all that around. mg minus m equals 2.5 g. mg minus 1 equals 2.5 g. M equals 2.5 g divided by 9 g minus 1. So I now have an expression for m based on when I have a downward acceleration of 1, my normal force, which is the apparent weight, is 2.5 g. I now need to work out what happens at rest. Well, at rest, acceleration is 0. So the apparent weight n will equal m times g. Therefore, n will equal m times g, which is this 2.5 g on g minus 1 times g. And on a calculator, that would give me how many newtons? Uh, 2.5 by g squared, so 9.8 squared, divided by 8.8, that's 9.8 minus 1. That gives me that answer, which is 27.284 newtons. But if I want to list it as kilogram weight, then I need to divide it by g. So that answer divided by 9.8 gives me an answer of 2.78 Newton weight, kilogram weight. So I can give my answer in kilogram weights, or I can give my answer in newtons. But that's what the apparent weight will be when I'm at rest. If I'm accelerating upwards, so if I get a copy of this, if I'm accelerating upwards, so this is going to be m times g, this is going to be n, but my acceleration is going upwards at, I think, 2 meters per second squared. So my resultant force in the direction of motion, which is up, will be anything in the direction which is n, minus anything in the opposite direction, which is mg. So m times 2 equals n minus mg. N is going to equal 2m plus mg, where this is m. So I'm going to have two lots of 2.5 g's over g minus 1 plus 2.5 g times g over g minus 1 equals my new resultant force. For acceleration upwards of 2 meters per second squared, the apparent weight is either 32.85 newtons or 3.35 kilogram weight.